Physics Part 198. At the end of this section on emission spectra, you should be able to show an understanding of the existence of discrete electron energy levels in isolated atoms, that is, for example, atomic hydrogen, and deduce how this leads to the spectral lines. Distinguish between emission and absorption line spectra. Recall and solve problems using the relation of HF is equal to E2 minus E1. State that all electromagnetic waves travel with the same speed in free space and recall the orders of magnitude of the principal radiations from radio waves to Y rays. Or should it be X rays? Continuous line spectra. If white light from a tungsten filament lamp is passed through a prism, the light is dispersed into its component colors as illustrated in the figure. The band of the different color is called continuous spectrum. A continuous spectrum has all energy, all colors is called continuous spectrum. A continuous spectrum has all the colors and wavelengths between two limits. In the case of white light, the color and the wavelength limits are violet, about 400 nanometer, and red, about 700 nanometer. Since this spectrum has been produced by the emission of light from the tungsten filament lamp, it is referred to as an emission spectrum. Finer details of the emission spectra than is obtained using the prism may be achieved using diffraction grating. Continuous spectrum of white light from a tungsten filament lamp. A discharge tube is a transparent tube containing a gas at low pressure. When a high potential difference is placed across two electrodes in the tube, light is emitted. Examination of the light with the diffraction grating shows that the emitted spectrum is no longer continuous but consists of a number of bright lines. Such a spectrum is known as a line spectrum. It consists of a number of separate colors, each color being seen as the image of the slit in front of the source. The wavelengths corresponding to the lines of the spectrum are characteristics of the gas which is in the discharge tube. Line spectrum of hydrogen from a discharge tube. Electron energy levels in atoms. To explain how line spectra are produced, we need to understand how electrons in atoms behave. Electrons in an atom can have only certain specific energies. These energies are called electron energy levels of the atom. The energy levels may be represented as a series of lines against a vertical scale of energy, as illustrated in the figure. The electron in the hydrogen atom can have any of these energy values, but cannot have energies between them. Electron energy level for the hydrogen atom. Normally, electrons occupy the lowest energy levels available. Under these conditions, the atom and its electrons are said to be in the ground state. The figure represents a hydrogen atom with its single electron in the lowest energy state.